Welcome, ladies and gentlemen. So what I'd like to do is show you how to graph my linear inequality. Negative 4y plus 3x is greater than 8. Now, when graphing the inequality, there's a couple different ways we could do it. We could use our intercept method, but for this case, I'm going to use the slope-intercept method because both 4 and 3 cannot divide into 8. So that means my intercepts are going to be dealing with some fractions, which I don't really want to have happen, especially the x-intercept will be a fraction. So if I convert it to slope-intercept form, then I can identify what is the slope in the y-intercept, and I can quickly graph. So to do that, I got to convert this equation in standard form over to slope-intercept form. So to do that, I need to solve for my y. So I see my y is being multiplied by -4 and being added by 3x. So I need to undo what's happening to the y, and I always undo addition and subtraction first. So therefore, I have negative 4y is greater than negative 3x plus 8. I wrote the negative 3x in front of the 8 rather than 8 minus 3x because I'm trying to put it into this format. Then the next thing I need to do is now divide by a -4 on both sides, and I have y. Remember, whenever we multiply or divide by a negative number, we have to now flip the sign. So now it's y is less than, and then negative 3 divided by -4 is now a positive 3/4 x. 8 divided by -4 is -2. So therefore, I can identify that my slope is equal to a positive 3/4, and my y-intercept is equal to -2, which should also be written as the coordinate point 0, -2. So to graph this, the first thing we want to do is always plot the y-intercept. That's the basic thing, and I see a lot of students that get into graphing, and they don't even graph the y-intercept. Plot the y-intercept, 0, -2, right here. Now what I'm going to do is I'm going to use the slope. I feel like I did this problem again. I guess I'll just go ahead and do it. So anyways, I'll go ahead and use the slope, which will be 3/4, to go up 3 units, 1, 2, 3. And then I can go over 4 units, 1, 2, 3, 4. So I'll go up 3 over 4 from my y-intercept. That's going to determine my next point. Now, I also need to determine, is my line going to be a part of the solution or not? And you could use test points if you like to. You could test these 2 points, plug them into your inequality, see if they're true or false. If they are part of the solution, then you're going to have a solid line. If they're not, you're going to use a dashed line. We can also look at our inequality symbol. And if our inequality symbol is less than or greater than, then it's going to be dashed. When it's less than or equal to or greater than or equal to, we use a solid. So therefore, I'll go ahead and create a nice little dashed line here. All right, and now the last thing we want to do is determine, well, what about the points above and below the inequality? Are those true or are those false? So the best point to be able to test for that is 0, 0, as long as your line does not go through 0, 0. Because if it goes through 0, 0, then you're testing the line, not testing points above and below the line. So to test the point 0, 0, which is at my origin, all I'm simply going to do is plug in 0 for y and 0 in for x. Therefore, I have 0 is less than -2. Well, 0 is not less than -2. That's false. So since this point is false, that means all the points above it are false, and all the points below it are going to be true. So there you go, ladies and gentlemen. That is how you graph your linear inequality. Thanks.